Okay. Well, the weather has changed pretty quickly here, huh? I'm not sick. I have bad allergies, so that's what you're hearing in theory. Or I have the plague. One of the one of those two. My problem I whenever there's weather changes, and I just came from Florida at a conference in the Caribbean. I do all my conferences on cruise ships. Pro tip. Um, but Yeah, so I came back to a pretty drastic weather shift. I have environmental allergies, so it's like pollens and stuff like that, and they seem to flare whenever it goes from like warm to cold or cold to warm. Just like quick shifts in temperature. Like if it's gradual over a 2 month period, it's not a problem. Well, when I get slammed from the side, I mean, it was nice here before I left, and then when I got to Florida, it was more humid but similar weather. So I didn't have a problem on the front end. But when I came back, it was like 90 and I landed and it was, I don't know, 46 or something. Oh, well, the ship had to go around it. We were in a port that got hit by Milton as a category 5 on its way to Florida in the Yucatan Peninsula at the end. But I mean, the damage, it must have just got skimmed at the north. So it wasn't, so I was east coast of Florida, and then down in the Caribbean. So from our perspective, it wasn't anything significant. I'm sure the folks on the west coast of Florida maybe have some differing opinions to that, but we had rain one day, and it happened to be the conference day, like the main conference day. The rest of us poster sessions and stuff. So I wasn't probably going to be outside much that day, anyways. Okay, so let's take a look at this exam. Let me make sure everybody, I'm just recording and stuff. I'm sharing my screen. Okay. So I assume everybody had a nice, relaxing week of programming. Hopefully, you spent quite a bit of time uh, working on the practice stuff, and hopefully you saw the practice stuff translated reasonably well, I think, to the midterm. Um, Remember again that uh, the if you did poorly on the midterm and you do better on the final, I'll replace whatever you got on the midterm with your final exam grade. So this isn't a sink the ship situation. Here, I'll just go this way. All right, so and then also hopefully as you were working on the practice questions, you saw I had 20 videos up, one for each of the questions where I went through and talked about it and things like that. So when you got stuck, hopefully you were able to go and get yourself unstuck. All right, so let's look at some of these. Close this. And all right, so just put a little comment thing up here so I can put the question. Okay, so we're supposed to write a function that takes, this is number one, write a function that takes a string as input and returns the smallest character based on the ASCII value. So you can ignore spaces and non-alphabetic characters. So we're only supposed to be looking at letters in this. So that means it might be helpful to be able to detect a letter, right? So you may have, hopefully you saw as you were going through the practice stuff, you saw that solving the problems with little tiny steps is often the way to do it. So writing either a lot of helper functions where which could be beneficial to us here. So I'm going to go ahead and I'm going to write a quick little helper function that returns a Boolean called isLetter, takes a character in as a parameter. I'll implement it afterwards here. And all this guy is going to do is return true if whatever was passed in is between A and Z lowercase or A and Z uppercase. So we're going to say return C greater than or equal to a lowercase a and C less than or equal to a lowercase z, or C greater than or equal to an uppercase a and C less than or equal to an uppercase z. If either of those things are true, return true. Otherwise, it's not a letter. All right. So then we're going to have our function that's going to return a char, maybe called find smallest. And this guy is going to take in a string as a parameter. All right. Pretty much whenever we're working with a string, especially if we're dealing with it on a per character basis, we're going to have our loop that's going to go through the whole string. So we can start off by writing that. Print I is equal to 0. I is less than s dot length. I plus plus. All right, so there is our loop that goes through, takes I on a voyage between 0 and s dot length minus 1, and we're going to use that integer to access an individual character in the string. What character are we interested in this time through? S at bucket I is the character we are interested in. All right, we only want to do something with this if that guy's a letter. So if is letter S at bucket I. So if I'm looking at a letter, this guy potentially is the smallest letter in my um, my string. Okay. Now, one thing I could do is I'm going to say char smallest, and I'll start that guy off as a question mark just as a default value, because currently I haven't found any characters. You could have set it to whatever was at bucket 0, but since we don't necessarily know if that was a letter or not, I'm just going to set it to a default value of something that I know is not a letter. So if we're looking at a letter, then we're going to ask another question. If smallest is equal to a question mark, which means this is my first time through, I haven't looked at any characters yet. So if smallest is equal to a question mark, I'll go ahead and set smallest equal to S at bucket I. I don't have to compare anything here. This is the first letter I found. All right. Otherwise, if I already have something inside of smallest, then what do I want to do? I want to ask the question, if, and we're returning smallest, right? So if S at bucket I is less than smallest. And remember, chars are stored as integers. So I'm asking, is the ASCII value of the current character I'm looking at smaller than the ASCII value that's stored inside of smallest? If that's true, then I have a new winner. Overwrite smallest with my new smallest value. Go through there, do that for the entire string. When all is said and done, smallest should have the smallest character that is a letter inside of that string. In this particular case, it would return a question mark if there's not any letters in the string, which is fine. It's within the spirit of the question, I guess. Write a function that takes a string as input and returns the smallest character based on its ASCII value, ignore spaces and non-alphabetic characters. All right, so questions about that one? We can go ahead and test it here, even though for the exam I suggested you, well, I requested you not test it, but you're only hurting yourself again. Let me go ahead and put using namespace std up here. So now I can go ahead and do a cout on find smallest of hello. Let's go hello world. Oh, it didn't finish the parenthesis for me. So there is D is the smallest letter in hello world. Okay. Next question. Let's see if I can hide those. Write a function that takes an integer n and returns the sum of all the odd numbers between 1 and n. So hopefully this one was fairly straightforward. All right. So this guy is going to be returning a sum. So it's going to return an integer. Let's call this guy sum odds. It's going to take in some integer n as a parameter. I'll go ahead and implement it. Oh, I'm in my prototyping thing down here. Let me move this above main. Go and implement it. All right. So we can create a for loop for int I is equal to 1. I is less than or equal to n. From 1 to n, I think it's reasonable to assume that goes all the way up to it. I is equal to I plus 2. 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. Just walk through it oddly, whatever. If you wanted to write a normal for loop that went I is 0 or I is 1, I is less than or equal to n, and then each time through just say if I mod 2 is equal to a 1, that means it's an odd number. You can ask the question for odd numbers as well, or you can just walk through the odds. We're going to need a variable to keep our sum. Each time through, we'll say sum is equal to sum plus the current value of I. Then return sum. So sum odds takes an n in as a parameter. We're going to keep a variable for holding our sum. We're going to spin through all the numbers between 1 and n, including n. Each time we're going to increase I by 2 to keep us with odd numbers and just add the current value of I to sum each time along. In the end, return the value of sum. So that's sum odds. Questions on that one? All right. Next one, write a function that takes a string and returns a new string where all the vowels are replaced with the character asterisk. Okay. Oh. Right. I'm going to go ahead and move these guys up by where I put the question, just so things are kind of organized a little bit better. All right. So for this one, it looks like it might be helpful for being able to detect vowels. Is what I'm looking at a vowel? Now, nothing prevents you from just writing that logic into your single function, but why not write a little function that just detects vowels real quick? So this guy will be a bool is vowel. This guy will take a char as a parameter. We'll go ahead and implement this guy. Now, if you only did lowercase as the example kind of showed, that's fine. I'll go ahead and do lower and upper. So I'll create a string lower A, E. Actually, let's just do string vowels. This is A, E, I, O, U, A, E, I, O, U. All right, and we want to go through and check to see if whatever character was passed in is found somewhere in here. If it is, it's a vowel. If it's not a vowel. So we'll write our stock for loop for spinning through a string. For int I is equal to 0, I is less than vowels dot length I plus plus. If vowels at bucket I is equivalent to the character that was passed in, if I found it somewhere in there, go ahead and return true. It's a vowel. If I've checked everything in the string and I never found a match for any of the lowercase or uppercase vowels, I'll return false. This is after the for loop is done. So there's our is vowel. Okay. So now we're supposed to write a function that takes a string and returns a new string where all the vowels are actually replaced by an asterisk. So we're going to, so here, let's call this, it's going to be return a string because we are returning a new string, not necessarily displaying it. So this guy is going to be called replace vowels. This will take a string s as a parameter, or name it whatever you want. We'll go ahead and implement it down here. All right. Typically, when we are doing something with strings and we're asked to modify a string in some way, we're probably going to be building a brand new string, okay, because strings are read only. So we'll go ahead and just say string answer is equal to the empty string. We'll write our for loop for int I is equal to 0, I is less than s dot length. I plus plus. So this for loop is going to be what we're going to use to go through every character of S. We'll ask the question, if is val S at bucket I. Let's see, did it give me all my parentheses that time? There we go. Must have written it. Oh, last time I did the S at bucket I initially and then wrapped it in the function and it reused my second parenthesis as the closing thing for the function call. I was missing a parenthesis on the previous one that was the error I had. All right, so if the current character I'm looking at is a vowel, we're supposed to replace all vowels with an asterisk. So I'll go ahead and say answer is equal to whatever answer currently is equal to concatenated with an asterisk. If it's not a vowel, then I'll just tack on whatever I'm currently looking at onto my string. After I've done that for all of the characters, I'll go ahead and return my answer. So replace val takes in a string, creates a new string to build up my answer inside of, spin through every character of the string that was passed in. Every time I run into a character that is a vowel, don't concatenate on the vowel, instead concatenate on the asterisk. Otherwise, just concatenate on whatever I found, the non-vowel. We're going to keep that. After I've done that for the entire string, go ahead and return my new string I built up. Answer. All right. Questions on that one? All right. Let's see what's next. Count number of words. Write a function that takes a string as input and returns the number of words in the sentence. You can assume that words are separated by a single space. Okay, so every single time we hit a space, that's the end of the previous word, right? All right, and we're supposed to count how many of those guys we run into. Now, one thing you could do, let me all right. So just as a quick example, if I have a sentence like that, and I know that's a nonsensical sentence, but those are the words I'm used to typing when I'm teaching coding. So, I don't know why, actually. That's just something that's happened over the years. If I look at that, I see that there are 4 words, right? How many spaces are there? 3? Couldn't I go through and just count the number of spaces and add 1? That's the number of words. Now, you could go through, build up a word. As soon as you hit a space, you say, I now have finished one word, empty out that word, move on to the next word. You could do that. You could detect words in case you needed the word. In this particular case, we don't actually need to do anything with the words, right? I actually had originally written this question to be a little bit more complex. I had it count the number of words that had at least 5 characters in it. Actually, I went back and I changed it after one person had already done the exam, but they had gotten it right. So I didn't, it didn't really impact them, but nobody else had started the exam yet. Just to make it fit into a time thing a little bit better. So I took off the second logic of it, of only count the number of words that have at least 5 characters in it. All right, so one way we could write this. So int count words takes a string, call it a sentence here. And I'll go ahead and I'll write it both ways just so you can see. The other way is not wrong, it just was overkill. So since I'm counting some stuff, I'll start my counter off at 0. I'll go ahead and write my for loop to go through every element of a string. For int I is equal to 0, I is less than s dot length, I plus plus. Each time through, we're going to say if s at bucket I is equivalent to a space, we'll say count plus plus. Ay, ay, ay. And then in the end, I'll just return 1 greater than count. 1 bigger than the number of spaces I found. So that's one way you could have written it. All right. Probably now that you've seen it, you're like, why didn't I write it that way? But it gets the job done. But if you didn't see it, it's not the end of the world. So you could instead have written this as, maybe we call this string temp. start off as the empty string. So as soon as I hit a space, I'm going to increment. Well, as soon as I hit a space, among other things, I'm going to be resetting temp to build up my next string. If I wasn't looking at a space, then temp is equal to temp concatenated with sentence. And I named my string sentence, not S. So I'll concatenate on the next character. If I'm not looking at a space, I'm building up the current word inside of temp. All right. If I hit a space, then I can go ahead and say I just finished a word. So I can go ahead and say count plus plus. So notice the same logic is here, right? Still looking for spaces. And then I go through all this every single time through. I am either emptying out my temporary string as I'm capturing the current word, or I'm just tacking onto it because I must be in the middle of a word. When all is said and done, I still have to return count plus one, or you could have started count off at 1 up here. The danger of starting it off at 1 is that what if you didn't have any words in your sentence? I wouldn't take off points. If again, I expected you to write this without testing it, so I expect there to be some small little logic holes or something like that in there. I'm looking for, does this person pretty much know what's going on? Or do they need the wake-up call that they need to spend more time working on this? Hopefully all of you are seeing now that I wasn't lying when I said week 1 of class that you have to put in the reps. You can't just cram for coding. It's a thing. It's not, I didn't make up the rules. This is just how coding works. So while I'm sure there were several 4-letter words said with my name on attached to it over the last week, I think you'll probably thank me for it as seniors in a while. All right. So if I had kept that second part in here, asking about only counting the number of sentences that had at least 5 characters in it, what you would have done up here is before you incremented count here, you would have just said if temp.length is greater than or equal to 5, only under that circumstance will I increment my count. You'd have to then throw one extra if statement afterwards because you do have your final string kind of stuck in there. I will show you kind of an interesting thing for those of you who've seen this before. So down here, I could say return count plus. Now this is going to look weird. I'm going to say temp.length greater than or equal to 5, question mark, 1, colon, 0. All right. We can all agree that looks weird. So what's going on here? So as we're going through our string, along the way, every single time I hit a space, that means I'm at the end of a word. I'm asking the question. This is only for that example where I had changed it. I had made the question a little easier by taking out the requirement of only counting words with the least 5 characters on it, which is not the question I asked. I asked the question, just tell me how many words there are. But if I had left that in there, now I'm saying if the current word I was just building up had at least 5 characters in it, then we're going to go ahead and count it. Whether I counted it or not, I'm still going to empty it out and move on with life. Now, when I'm done with this for loop, I presumably do have my very last string still trapped inside of my string called temp, my very last word, right? I didn't hit a final space. I hit the end of the string. So I'm going to go ahead and return count plus something. This guy right here is called an inline if statement. If I put the syntax here, this is Boolean expression followed by a question mark, followed by true value, followed by a colon, followed by false value, semicolon. So this is called an inline if statement. It will boil down to either the true value or the false value, depending on whether or not this Boolean expression is true. So what I'm saying here is temp.length greater than or equal to 5. If that's true, boil down to a 1. If that's false, boil down to a 0. Regardless of whether it was a 1 or a 0, I'm adding it on to my running count. Now, you might go through your entire career and never use an inline if statement. But I'm sure that some of you have probably looked at some code examples online or something like that and maybe seen somebody bump into a funky thing like this. That's what it is. I would throw this into a similar category of like the plus plus versus the plus plus coming before versus the plus plus coming after. If you know, you could take advantage of it. If you don't, you could accomplish this exact same logic with it by wrapping it in an if statement. You add 3 or 4 lines to your code. You're saying, if its length is greater than 5, return count plus 1, else return count. You get the same output. So if you don't like the funky logic, you never have to use it. You're never going to lose points or something like that. But I wanted you to see it at some point. Okay, so questions about that guy. A couple different renditions of that there, but go ahead.
Like, is it just comes with time learning all this stuff? Because like most stuff you do, I understand, but then some of the stuff like you do with the 5 question mark 1, like, is it just with time you come to learn different specialty tools or
like? Give me an example of which thing. I mean, I think the short answer to your question is yes, but give me an example of what you.
Like you just explained, like how you know that the 5 question mark 1, like that. Is that just something that just with your experience being in the job?
Yeah, so his question for those of you that are online, he's saying like when you run into weird crap like this, is this just time in that you learn those things? I mean, the answer is yes. I would call this something you would only see from, I don't know, old school programmers, people who've coded for a long time. Because we didn't have the power tools that we have today to kind of get used to other things, even though this is kind of a shortcut. So in some ways, modern programming, I think, makes things even a little bit longer, where there used to be this thought of we want to keep things as small as possible, even file size. Okay. But at some point in there, it was just kind of like, I think programmers get an ego thing going on where they're like, oh, let me write the thing that's the hardest to understand. That way I have job security because nobody else can fix my code. Something like that. But, in terms of how I learned the stuff, I mean, I've been programming since I was 9. So just over time, at some point I ran into a situation where either I saw this and had to go figure it out, or I learned about the syntax and I went and used it and saw some places where it could be handy. And every now and then you do run into a situation where being able to put an inline if statement in there, like something like this, where I'm going to either add something or not, but I kind of want to say it all in one little breath instead of wrapping it in an if statement. Every now and then you run into a situation where that's actually fairly handy, but it's kind of one of those things that might be difficult to come up with an exact example of something where it really is a life-changing thing. I feel pretty confident in saying that you could go through your entire career and never write an inline if statement and be just fine. But yeah, I would say little tricky syntactic sugary stuff like this just comes with you bumping into it over time, just like any other life experience. But I'll never test you over stuff like this. This is more of, I don't know, coding trivia type of stuff. All right. Going here. Next one, write a function that checks whether 2 given integers are coprime, meaning their greatest common divisor is 1. Oh, and also just add on to my answer a little bit to your question. Also, remember in class, I had mentioned that you will understand the solution when you see it way before you'll be able to write it on your own. So if that's where you are right now, that's okay. That's why I give you a do-over in the midterm with the final exam. I've been doing this a while. Okay. My goal in life is not to fail all of you. I'd be just as happy giving everybody A's. Okay. But I do want you to become good programmers or talk yourself out of becoming a programmer. This just isn't your cup of tea. Okay. Now, some of you might end up being really good computer scientists. You just go down a path of jobs that, hey, I don't want to be doing a whole lot of this, right? But you might be really geeky and stuff like that. So at that point, you just kind of, get through the 2 coding classes and look at like a cybersecurity concentration or something like that, and go and do that side of technology. I mean, we need those folks. I like to call programmers real computer scientists, but that's not true. I mean, we have all, you would never want me working on your user interface. Ever. I don't even update user interface. I think I showed you guys the auto clicker thing I modified. Was that in here? I didn't even change their user interface from that to be more in line. I just stole one of their text boxes and just decided I know what it means. That's my weakness. I'm good at the coding backend stuff. I'm not interested in the other things. There's going to be people in here who are like, I don't want to do the coding backend stuff, but I want to do the technical front end stuff. We need both in order to, in fact, most people care about what the software looks like more. They make the assumption it's going to work. But so say this again. Well, and that's actually the original joke. I mean, let's see if I can find for those of you who've seen some of my, oh, there it was. It was already right here. See that guy? That is my user experience for my very first iPhone app. My user interface, rather. How many of you would buy that app? That app made $3 million when the App Store first went live. Everybody and their brother bought every single app. This was a dice roller for playing Dungeons and Dragons. Now, if you go onto the App Store now, there's 4 zillion dice rollers. But early, at the very beginning, I was the only dice roller in town. This was 99 cents. I had a pro version that allowed you to do like things like 2d6 plus 8, that kind of stuff. That was $1.99. So combined, the two of them made that much. But yeah, you would not want to hire me for user interface stuff. In fact, years later, once you put it up on the App Store, it just sits there. Years later, Apple ended up kicking it off the App Store for not meeting their user experience standards. It was no longer making any money. Nobody had bought it probably in 3 years by the time they kicked it off. So it made all of that in like the first 6 months of the App Store. This was up the day the App Store went live. So we all bring different talents to the table. All right, write a function that checks whether 2 given integers are co-primes, meaning their greatest common divisor is 1. Now, we know that every 2 numbers will be evenly divisible by 1. We want to make sure that that's the largest value that evenly divides it. Make sense? Now, you could do this a couple different ways. If you remember from the practice stuff, there was the greatest common divisor question that had you implement like the Euclidean algorithm or something like that. So what we might do is we might say, what is it? R co-primes, int A, comma, int B. And this guy's going to return a Boolean. True if they are co-primes, false if they're not. All right, so what I want to do is I'm going to start off just saying, what is the greatest common divisor of both these numbers? And I'll do it the brute force way. If you watch the video where I went and showed you how to take I mean, that was a good question on the practice thing where I said, hey, there's this thing that exists called the Euclidean algorithm that some math geniusy guy came up with. And here's the algorithm. Here's the 6 things you do to make that work. And you just translate pseudocode into C++ and poof, it works. Okay. You could do that if you want, or you could just brute force it and just say, hey, I'm gonna do it myself. So we're gonna go ahead and we know that the largest value that evenly divides A or B is the smaller of A or B, right? So I'll go ahead and say int smaller, and I'm just gonna guess that A was the smaller of the two values. Then I'll say if B is less than A, I'll update smaller to actually be B. So now I know that the variable smaller holds the largest possible value that could evenly divide A and B. All right. So now what I'm trying to do is I'm trying to whittle that down. I'm trying to whittle that down to find out what is the largest value that evenly divides both of them. These guys are coprimes if the largest value is a 1. All right. So we're going to have our loop for int I is equal to smaller, which is the largest value that might evenly divide both of them. We're going to keep going as long as I is greater than or equal to 1. Each time through, we're going to say I minus minus. We're going to ask the question, if A mod I is equal to 0, and B mod I is equal to 0. And I like putting those in parentheses, just it makes it look a little cleaner, I think. If both of those are true, that means I have found a value I that evenly divides both of these guys, right? All right. So we're going to call this guy common divisor. And we can start off at -1. We know it'll eventually get set to something. So if I found a value that is a common divisor, not necessarily the greatest, I mean, at this point, the first time it hits, it would be the greatest common divisor, but that's not what I'm interested in. I want to know if 1 is the only common divisor. So I'm not even interested in what these guys are. I'm interested in how many I run into. So common divisors, we initially have 0. We know we will have 1 when all is said and done. At least 1, because we know that both numbers are evenly divisible by 1. So we'll go through all of them. If I find a common divisor, I'll say common divisor plus plus. I found a common divisor. When all is said and done after this for loop, we know that common divisor will be at least 1. Because this loop goes all the way down to 1, and we know that 1 will evenly divide both of them. So we want this guy to return true if A and B are coprimes, which means that they have a greatest common divisor of only 1. So if, well, actually, we'll just return common divisors equal 1. If after going through and counting all the common divisors we found, I have only found 1, the one you found was a 1. So we'll return whether or not common divisors is equivalent to 1, which means there is only one value that evenly divides both of those. Good.
But you have to define common divisors.
Didn't I? Oh, I just didn't put the. There you go. Thank you. All right, makes some sense. So in this case, we're just counting the number of common divisors. And if that count is only 1, that means the only thing that evenly divided it was 1. Questions on that one? Next one. Write a function that takes a string sentence as input and returns a new string where each word is reversed, but the word order stays the same. Okay, so now we can kind of use some of the logic from one of our other ones, but we're going to go ahead and we need a tool that reverses, right? So let's go ahead and write a function called string, maybe called reverse string. This guy takes a string s as a parameter. I'd like to say I did that for your benefit, but I did it for my benefit because I can't see the screen very well. All right. Reverse string. Well, and by the way, in the future, I mean, maybe it wasn't a problem for anyone, but if the font is too small, just yell at me, tell me. Because pretty often I'm using my computer with one of my VR headsets. So my computer screen's the size of a movie theater. So it's possible I've reduced my font on my laptop because it was that big in the headset. So feel free to tell me to make the font bigger or whatever, and I'll do as you command. All right, so reverse string, we're going to go ahead and just create a place to store our final string in. We're going to write our loop that walks the string from end towards beginning. So for int I is equal to the last legal bucket in our string, which is s dot length minus 1. We're going to keep going as long as I is greater than or equal to 0. We're going to subtract 1 from I each time. And we're just going to tack on. Answer is equal to answer, blah, 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 blah. I do need to learn to spell. Answer, tack on s at bucket I. And then return answer. So reverse string, takes in a string, creates a new string to build up, walks the string it took in from end towards beginning, tacking on the character each time, returning now the reversed version of it. All right, and let's see. The function we're supposed to write for this question takes a sentence in as input and returns a new string where each word is reversed. Okay, so pretty similar to something we've already written. We're going to be returning a string, which is a sentence. Let's call it reverse words in sentence. Oh, and hold on, give me a moment. Get my prototypes up there. All right. So reverse words in sentence takes a sentence in as a parameter. We want to go through, we want to build up words. Then we want to reverse them and tack them onto our ongoing string. We run into a space. Does it say there's only separated by one space? Yeah, we'll just make the assumption it's separated by one space. Then we just keep the space, tack it on. All right. So we're going to go ahead and start our for loop for int I is equal to 0. I is less than s dot or sentence dot length I plus plus. All right. Now, as we go through here, we want to be building up words. So we're going to ask this question: if sentence at bucket I is currently equal to a space, That means I am between words. All right. Now, I needed to be building upwards here. So I'm going to need a variable, maybe called temp. We'll start temp off as the empty string. Okay. So and we're also going to need something to build up our answer in. So we'll say string answer is also equal to the empty string. Whenever I hit a space, I know I'm at the end of a sentence that I've presumably been building up inside of temp. So I'll go ahead and say answer is equal to answer concatenated with reverse string of whatever's in temp concatenated with a space to take into consideration the space we just ran into. Then I'll reset temp to the empty string. So whenever I bump into a space, tack on the reverse of the string you've been building up, and then empty that string out because you're between words. Otherwise, if I'm not looking at a space, I'm in the middle of building a word, so I'll say temp is equal to temp concatenated with sentence at bucket I. I'll continue to build up my word. When all is said and done, I can go ahead and return whatever is already an answer concatenated with it would be one final space. This would be the end of the string. So we already have the space in there. All right. So I'll return answer followed by reversing the very last word I captured inside of temp. So temp is going to be what I use to hold my words as I'm building them. Answer is going to be my final result. Go through the entire sentence from beginning to end. If I'm looking at a space, I'm in between words. What do? I reverse the word I just finished building, and I tack it onto my running answer along with the space I just bumped into. Then I reset my word, so I'm prepared to build the next one. If I'm not looking at a space, I'm just going to continue building up the current word I'm building. After the for loop's done, I have one final word trapped inside of temp. I'll reverse it and tack it onto the very end of my string. All right. Questions on that one? Next one. Write a function that takes an integer n and returns the sum of all prime numbers between 1 and n. Okay, again, might be helpful for us to have a function that determines whether a number is prime or not. Prime number is a number that's evenly divisible by itself and 1. So we'll have a Boolean is prime, takes in some number. This is going to return true if it's a prime number and false if it's not. So if a prime number is a number that's only divisible by itself and 1, we can check all of the numbers between 2 and itself. Technically, there's some special cases like 2 is not prime and stuff, but you just use the brute force thing. If you want to throw an if statement in there, you can. All right, so there's our bool is prime. We'll have a for loop where int I is equal to 2, I is less than n minus, well, less than n is fine because we're not going all the way up to n. I plus plus if the current value of n, when divided by the current value of I, has a remainder of 0, that means we found another value other than 1 and the number itself that evenly divides it. Not prime. Right? After the for loop, If we're still alive, that means we didn't find any values. They evenly divided it. And we already know that 1 divides it and itself divides it. So if we found no other numbers in the middle, which means I'm still kicking when I get down here, because remember, return makes the function immediately end. So if I'm still kicking right here, I'm going to return true. We're looking at a prime number. All right, so now I have my test for primes. Takes an integer and returns the sum of all prime numbers. Okay, so we're going to be returning a sum, which is going to be an integer. Let's call this guy sum primes. Take an int n as a parameter. Call it whatever you want. All right. And it returns the sum of all prime numbers between 1 and n. Okay. So we'll say for int I is equal to 1, I is less than or equal to n, I plus plus. We'll have our sum is 0 to use to sum up all our primes. Again, this kind of skips the idea of our special cases. What is, I think 1 is not prime, right? I think that's a rule. 1 is not prime. So I don't care if you take that into consideration or not, as long as your logic is largely right. In fact, I'm not going to take into consideration here. If you want to, you can just start with 2 and move on with life. But we'll just leave it pretty straightforward. So we're going to sum up all the values that are prime here. So as I go through, I'm going to ask the question, if is prime of the current value of I, the current value of I is a prime number, then I want to say sum is equal to sum plus the current value of I. At the end, I'll return sum. Go through all the numbers between 1 and n. For each one, ask if it's prime. If it is, add it to your running total. After you've done that for all the values between 1 and n, return your sum. If you want to mess around a little bit with some of the special prime cases, you can, it's fine. This captures the logic of this whole thing. All right, questions on that one? And I'll put this code up when we're done. Go ahead.
Like starting prime is could you just start I at 2 instead of 1?
Yeah. If you wanted to account for not accidentally counting 1 as prime, that's fine. I guess what I'm getting at here is the question was not meant to drill you on, do you remember the special rules of whether a value is prime? If you assumed 1 was prime, that's fine. I'm not taking points off for that. Here, I gotta stand up for a second. My back's screaming after that one. That was a hard question. All right. So, any other questions on that one? All right. What am I doing? I was at a different angle before. All right. This guy. All right, write a function that takes a string and a character as input and returns the number of times that character appears in the string. Okay, so we're counting something, so we're probably going to return an int. Let's see, maybe called count occurrences. Spell that right? Sign of the apocalypse. All right, so we're going to write a function called count occurrences that takes a string and a character, and it returns the number of times that character is found in that string. Pretty straightforward. So we're going to have an int for our count. We haven't found any occurrences yet. We're going to have a for loop for int I is equal to 0, I is less than s dot length, I plus plus. All right, so that's our stock for loop for going through every character in a string. We're going to ask a question if the current character we're looking at is equivalent to the char we're trying to count. We'll say count plus plus. After we've done that for all of them, we can return count. So there's count occurrences. Takes a string, takes a char, creates a counter, remembering stuff. As we go through all this, keep thinking back to that slide. How do human beings solve problems? We remember stuff. We ask questions, repetition. Hopefully you're seeing programming that's it. That's all it is. What do I need to remember? What questions do I need to ask? How many times do I need to do this? Make sense? You're just getting used to problem solving that way. And that's where the reps come in. Because as you're walking through this, don't you find that I'm repeating myself many times, right? Your stock for loop that goes through every character of a string, that kind of stuff. These are just your fundamentals for solving almost any problem. Okay. Write a function that takes an integer as input and returns the greatest difference between any two digits in that number. Oh, I don't like that one at all. Jeez. Okay. You hate when you get to questions that just don't sound like they're going to be fun. That's terrible. What kind of teacher would give you that crap? All right, so in order to do this, I'm going to need to be able to differentiate individual characters in my string, right? And I think you had one of the questions in the practice thing kind of had you do this. Well, I think it was the one that had you sum the numbers inside of a digit, something like that. So kind of taking that skill and applying it here. All right, so something we're probably going to need for this one, since we are, instead of summing a bunch of digits, we're looking for the greatest difference between two digits. Write a function that takes an integer as input and returns the greatest difference between any two digits in that number. Okay, so first thing we're going to need, go ahead.
And then get minus string.
I see what you're saying. Well, the idea here is this function is taking in an int. So you're ultimately going to do that anyways. You're talking about what comes before you call the function. How do you read it in? I mean, you would then make your thing take a string, I guess, or whatever. So I mean, you could do it, but it's not going to change what this function is going to be. So let's see, we're returning the greatest difference. So we're going to return an int. The difference between two numbers would be an int. And this guy is going to, let's see, let's call it find greatest difference. It'll take an int n as a parameter. Go ahead and start writing this guy. We're probably going to create ourselves a little helper here in a minute. All right, so find greatest difference. First thing I'm going to do is I'm going to say string s is equal to string of n. So we'll go ahead and give ourselves the string version of that number. Now what we have is the ability of looking at bucket 0, which is one of the numbers, bucket 1, which is another number, bucket 2, which is another number. All right, but we're going to need a way of turning that number into a number. There are built-in the character version of like a 2 turning into the number 2. All right, there are built-in functions to do this, but assuming we don't know what those are, we're going to go ahead and say char to number. This will take a char c as a parameter. I'll probably go ahead and create my little string here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I know those are the kinds of values they're going to be passing me here, right? And I'm going to go ahead and search through that string for int I is equal to 0. I is less than map.length I plus plus. Each time through, I'll say if map at bucket I is equivalent to the character I'm looking for, return I, return where I found it. I'll find a 0 at position 0. I'll find a 1 at position 1. I'll find a 2 at position 2, so on and so forth. All right, so that's char to number. All right, so now what I'm going to do is I'm going to keep track of my per greatest distance, and I'll start it off at a -1 because we're going to be, we need to have an initial winner, right? So what we're going to do in this guy, and I'm going to kind of say it out loud since we're running short on time here, but what we're going to do in this guy is we're going to go through the string for the first number and see how far it is from all the other numbers. So when we're done with that one, we'll have current greatest distance set to some number. Then I'll go to the second character, get its distance from all the numbers. If any of them beat it, we'll replace it. Do that for every character in the string. In the end, current greatest distance will be whatever the farthest distance was between any two digits. Return that value. And let me just quickly look at what the last question was. Write a function that takes a string as an integer n and inputs. Actually, you know what? Both of these are pretty interesting questions. Since we're running out of time, rather than rush it, I'll just say that one out loud real quick too, but let's write it at the beginning of next class, just so we see both of them. But so the next one is write a function that takes a string as an integer and shifts, as well as a number, and shifts all the characters some number of positions. So we use ASCII to do the thing, but if we walk off the end of the alphabet, we have to wrap back around to the beginning. All right. This is actually based on an old encryption algorithm from Julius Caesar time called the Caesar cipher. Sometimes it's just called ROT13, rotate 13, because the alphabet has 26 characters in it. So if you go 13 in one direction, you can use the encryption and decryption identically to do it. All right, so any case, we'll do those last two questions at the beginning of class on Thursday. I hope to have all the exams graded, if not by tonight, sometime tomorrow. So you should have your good news or bad news or news, whatever it is. But again, keep your head up. I expect several of you to have struggled on this. Hopefully you just keep convincing yourself you got to just keep putting the reps in. All right. I'll see everybody on Thursday.
Actually,
What bad news? We got bad news.
I didn't take the midterm
Why?
because I didn't know.
Because you sucked.
Yeah.
All right. You didn't know.
No, I thought it was due another week from now.
Did you read? You don't know how to read.
Well.
It's apparently not.
Just leave it and then wait till the final, or
Well, I mean,
I still need to practice clearly from what I'm seeing.
so you would have struggled in it anyways. Okay. So I guess probably do that. I would still sit down and go through it just to give yourself the experience. So you do it, but I mean, it sounds like you're going to do crappy on it anyways. So it doesn't really matter. But ultimately the goal is that we want you to ultimately learn it.
Yeah, I just
right?
want to get better at it.
Yeah. So, but don't give up on your, there's two mistakes here, right? One, you've seen you need to put in more reps. The second one is you didn't know when it was due, but it sounds like it didn't really matter. You would have bombed it. So, so it doesn't really matter. You're going to replace it with your final exam score anyways.
So what's the next step for me?
I would take the exam if it's still up there, just so you get yourself some practice. You're going to do poorly on it. Our expectation is you're going to do better on the final anyway. So you really haven't hurt yourself.
Yeah.
In reality, make sure you're checking due dates better in the future, but go back and just keep practicing drilling these types of things. That's why I said go and do it anyways, because it's just going to give you more practice, more reps.
Okay.
Sound good?
Yep.
All right. So
Can you just pull up the code again? I just had a question. Let me just like, I also have a question. I said one. So the map
What am I doing? Did I screw up or did you screw
No,
up?
I was just like, so here, I think it's just because you're going quick. Notice how, do you have to always return like a -1 here? Because in case C isn't,
Yeah, I mean, I think I said it even out
Yeah,
loud
like
that
earlier.
we know how we're gonna use this. So we didn't ask the if statement, but you're right.
and so.
If
and it
somebody
would give
were-
you an error if you were
Um,
to not put a return.
Yeah, technically, in this case, it's gonna give me a warning, I think, in here. Because I've advertised I'm gonna return an int,
And-
yet it'll still run.
Yeah.
In C++, it's just a warning. It says, look, you told me you were returning an int, yet you only conditionally return something here.
And does that warning proceed and go into other languages in the future or?
Other languages, the warning turns into an error.
Okay.
It'll prevent you from testing
So
it.
you need to get used to doing that then.
Yeah.
Okay. Sounds good. All right, thank you.
Yep. What? Oh, hold on. Let me at least stop. Hold on. There was a chat real quick.
So I technically have 3 questions, but one of them you can answer later on Slack.
Okay. I do
I kept
I
on,
do curve exams when like necessary. Sometimes I'll ask a question. This is to Jennifer. Sometimes I ask a question that I intended for you to do it one way, yet maybe I didn't give you that tool, but I don't think that's the case on this test. So I probably won't curve it, but you get to get a complete do-over with the final exam. So I wouldn't worry too much about that. Typically, students either get an A or B or they get a D or F. There's usually nothing in the middle, so it's just a wake-up call for where you're currently at. All right, so I have that on.